CIET NCERT presents audiobook Ganit Prakash, textbook of mathematics for grade 7.
Chapter 8 Working with Fractions. Page number 173. On the right side of the page, a QR code is provided, scanning which additional resources to this chapter can be reached out. 8.1 Multiplication of Fractions. Arun walks 3 kilometers in 1 hour. How far can he walk in 5 hours? This is a simple question. We know that to find the distance, we need to find the product of 5 and 3. That is, we multiply 5 and 3. Distance covered in 1 hour is equal to 3 kilometers. Therefore, distance covered in 5 hours is equal to 5 into 3 kilometers. That is equal to 3 plus 3 plus 3 plus 3 plus 3 kilometers. That is equal to 15 kilometers. On this page, there is a picture of Arun with his pets, dog and a tortoise. Arun's pet tortoise walks at a much slower pace. It can walk only 1/4 kilometers in 1 hour. How far can it walk in 3 hours? Here, the distance covered in an hour is a fraction. This does not matter. The total distance covered is calculated in the same way as multiplication. In the figure, the line is divided into 3 equal parts with distance marked 1/4 kilometers as one part, distance moved in 1 hour. Distance covered in 1 hour is equal to 1/4 kilometers. Page number 174. Therefore, distance covered in 3 hours is equal to 3 into 1/4 kilometers. That is equal to 1/4 plus 1/4 plus 1/4 kilometers. That is equal to 3/4 kilometers. The tortoise can walk 3/4 kilometers in 3 hours. Let us consider a case where the time spent walking is a fraction of an hour. We saw that Arun can walk 3 kilometers in 1 hour. How far can he walk in 1/5 hours? We continue to calculate the total distance covered through multiplication. We have a figure given here in which a line represents 3 kilometers, that is, distance covered in 1 hour. It is divided into 5 equal parts. Distance covered in 1/5 hours is marked. Distance covered in 1/5 hours is equal to 1/5 into 3 kilometers. Finding the product. Distance covered in 1 hour is equal to 3 kilometers. In 1/5 hours, distance covered is equal to the length we get by dividing 3 kilometers into 5 equal parts, which is 3/5 kilometers. This tells us that 1/5 into 3 is equal to 3/5. How far can Arun walk in 2/5 hours? Page number 175. Once again, we have distance covered is equal to 2/5 into 3 kilometers. Here we have a picture in which the distance covered in 1 hour is given and it is divided into 5 equal parts, and distance covered in 1/5 hour is marked, as well as the distance covered in 2/5 hour is also marked. Finding the product. First, we can first find the distance covered in 1/5 hours. Second, since the duration 2/5 is twice 1/5, we multiply this distance by 2 to get the total distance covered. Here is the calculation. Distance covered in 1 hour is equal to 3 kilometers. First, distance covered in 1/5 hour is equal to the length we get by dividing 3 kilometers in 5 equal parts. That is equal to 3 upon 5 kilometers. Second, multiplying this distance by 2, we get 2 into 3 upon 5, that is equal to 6 upon 5 kilometers. From this, we can see that 2 upon 5 into 3 is equal to 6 upon 5. Discussion. We did this multiplication as follows. First, we divided the multiplicand 3 by the denominator of the multiplier 5 to get 3 upon 5. It is also given in the figure here, 2 upon 5 into 3, where 2 upon 5 is the multiplier and 3 is the multiplicand. Page number 176. We then multiplied the result by the numerator of the multiplier, that is 2, to get 6 upon 5. Thus, whenever we need to multiply a fraction and a whole number, we follow the steps above. Here, in the figure, the process of multiplication is explained. We have multiplier as 2 upon 5 and multiplicand as 3. So, 2 upon 5 into 3 is explained as 3 divided by 5 is equal to 3 upon 5, and from 2 upon 5, 5 is the denominator. In 2 upon 5, 2 is the numerator, which is multiplied by 2 into 3 upon 5, that is equal to 6 upon 5. Example 1. A farmer had 5 grandchildren. She distributed 2 upon 3 acre of land to each of her grandchildren. How much land in all did she give to her grandchildren? 5 into 2 upon 3 is equal to 2 upon 3 plus 2 upon 3 plus 2 upon 3 plus 2 upon 3 plus 2 upon 3 is equal to 10 upon 3. Example 2. 1 hour of internet time cost 8 rupees. How much will 1 whole 1 upon 4 hours of internet time cost? 1 whole 1 upon 4 hours is 5 upon 4 hours. Converting from a mixed fraction, cost of 5 upon 4 hour of internet time is equal to 5 upon 4 into 8. That is equal to 5 into 8 upon 4. That is equal to 5 into 2. That is equal to 10. It costs 10 rupees for 1 whole 1 upon 4 hours of internet time. Figure it out. First, Tenzin drinks 1 upon 2 glass of milk every day. How many glasses of milk does he drink in a week? How many glasses of milk did he drink in the month of January? Question number 2. A team of workers can make 1 kilometer of a water canal in 8 days. So, in 1 day, the team can make dash kilometer of the water canal. If they work 5 days a week, they can make dash kilometer of the water canal in a week. Question number 3. Manju and 2 of her neighbors buy 5 liters of oil every week and share it equally among the 3 families. How much oil does each family get in a week? How much oil will one family get in 4 weeks? Question number 4. Safia saw the moon setting on Monday at 10 p.m. Her mother, who is a scientist, told her that every day the moon sets 5 by 6 hours later than the previous day. How many hours after 10 p.m. will the moon set on Thursday? Page number 177. Question number 5. Multiply and then convert it into a mixed fraction. A. 7 into 3 upon 5. B. 4 into 1 upon 3. C. 9 upon 7 into 6. D. 13 upon 11 into 6. So far, we have learnt multiplication of a whole number with a fraction and a fraction with a whole number. What happens when both numbers in the multiplication of fractions. Multiplying two fractions. We know that Arun's pet tortoise can walk only 1/4 kilometers in 1 hour. How far can it walk in half an hour? Following our approach of using multiplication to solve such problems, we have distance covered in 1/2 hour is equal to 1/2 into 1/4 kilometers. Finding the product. Distance covered in 1 hour is equal to 1/4 kilometers. Therefore, the distance covered in 1/2 hour is the length we get by dividing 1/4 into two equal parts. Here we have two columns, one for hour and the other for distance, in which we have two rows. In the first row, 1 hour, and in the distance we have 1/4 kilometers. In the second row, 1/2 hour, and you need to fill the distance in the second column. To find this, it is useful to represent fractions using the unit square to stand for a whole. In the picture, we have a unit square representing a whole. And in the next picture, we have a square which is divided into 4 equal parts, and 1/4 of the part is shaded yellow. Page number 178. Now we divide this 1/4 into two equal parts. What do we get? What fraction of the whole is shaded? Since the whole is divided into 8 equal parts and one of the parts is shaded, we can say that 1/8 of the whole is shaded. So the distance covered by the tortoise in half an hour is 1/8 kilometers. This tells us that 1/2 into 1/4 is equal to 1/8. In the figure, we are provided with a square which has 1/4 part yellow in color and half of 1/4 part as a shaded portion. If the tortoise walks faster and it can cover 2/5 kilometers in 1 hour, how far will it walk in 3/4 of an hour? Distance covered is equal to 3/4 into 2/5. Finding the product. First find the distance covered in 1/4 of an hour. Second, multiply the result by 3 to get the distance covered in 3/4 of an hour. First, distance in kilometers covered in 1/4 of an hour is equal to the quantity we get by dividing 2/5 into 4 equal parts. Taking the unit square as the whole, the shaded part in figure 8.1 is a region we get when we divide 2/5 into 4 equal parts. How much of the whole is it? The whole is divided into 5 rows and 4 columns, creating 5 into 4 is equal to 20 equal parts. Number of these parts shaded is equal to 2. So, the distance covered in 1/4 of an hour is equal to 2/20. We are provided with a figure 8.1 which has a unit square in which 2/5 of the part is colored in yellow, and this yellow portion is divided into 8 equal parts, out of which 2 parts are shaded. Page number 179. Second, now we need to multiply 2/20 by 3. Distance covered in 3/4 of an hour is equal to 3 into 2/20. That is equal to 6/20. So, 3/4 into 2/5 is equal to 6/20. That is equal to 3/10. We are provided with a figure here. Figure has a unit square in which 2/5 part is colored in yellow. This is divided into 8 equal parts, out of which 6 are shaded. Discussion. In the case of a fraction multiplied by another fraction, we follow a method similar to the one we used when we multiplied a fraction by a whole number. We multiplied as follows. 2 by 5 divided by 4 is equal to 2 upon 20. Divide the multiplicand by 4. 3 into 2 upon 20 is equal to 6 upon 20, that is equal to divide the multiplicand by 3. Using this understanding, multiply 5 by 4 into 3 upon 2. First, let us represent 3 upon 2. Taking the unit square as the whole, since the fraction 3 upon 2 is one whole and a half, it can be seen as follows. Following the steps of multiplication, we need to first divide this fraction 3 upon 2 into 4 equal parts. It can be done as represented in the figure 8.2, with the yellow shaded region representing the fraction obtained by dividing 3 by 2 into 4 equal parts. What is its value? We observe that the whole is divided into 2 rows and 4 columns, creating 2 into 4 is equal to 8 equal parts. Number of parts shaded is equal to 3, so the yellow shaded part is equal to 3 upon 8. In figure 8.2, we have here a unit square with 8 equal parts and 2 parts are shaded. This fraction is represented clearly in this figure, page number 180. Now, the next step is multiplying this result by 5. This gives the product of 5 by 4 and 3 by 2. 5 by 4 into 3 by 2 is equal to 5 into 3 upon 8, that is equal to 15 upon 8. Connection between the area of a rectangle and fraction multiplication. In the figure 8.3, what is the length and breadth of the shaded rectangle? Since we started with a unit square of side 1 unit, the length and breadth are 1 upon 2 unit and 1 upon 4 unit. What is the area of this rectangle? We observe that 8 such rectangles give the square of area 1 square unit. So, the area of each rectangle is 1 upon 8 square units. This fraction has been represented in the figure 8.3. We have 8 equal parts, out of which 2 are shaded yellow and one portion of this is shaded to represent 1 upon 8. Do you observe any relation between the area and the product of length and breadth? The area of a rectangle of fractional sides equals the product of its sides. In general, if we want to find the product of two fractions, we can find the area of the rectangle formed with the two fractions as its sides. Figure it out. Question number 1. Find the following products. Use a unit square as a whole for representing the fractions. A. 1 upon 3 into 1 upon 5. B. 1 upon 4 into 1 upon 3. C. 1 upon 5 into 1 upon 2. D. 1 upon 6 into 1 upon 5. Now find 1 upon 12 into 1 upon 18. Page number 181. Doing this by representing the fractions using a unit square is cumbersome. Let us find the product by observing what we did in the above cases. In each case, the whole is divided into rows and columns. The number of rows is the denominator of the multiplicand, which is 18 in this case. The number of columns is the denominator of the multiplier, which is 12 in this case. Thus, the whole is divided into 18 into 12 equal parts. So, 1 upon 18 into 1 upon 12 is equal to 1 upon 18 into 12. That is equal to 1 upon 216. Thus, when two fractional units are multiplied, their product is 1 upon product of denominators. We express this as 1 upon b into 1 upon d is equal to 1 upon b into d. In the given figure, we have 18 rows and 12 columns, thus dividing the whole unit into 216 parts, out of which one part has been shaded representing 1 upon 216. Question number 2. Find the following products. Use a unit square as a whole for representing the fractions and carrying out the operations. A. 2 upon 3 into 4 upon 5. B. 1 upon 4 into 2 upon 3. C. 3 upon 5 into 1 upon 2. D. 4 upon 6 into 3 upon 5. Multiplying numerators and denominators. Now find 5 upon 12 into 7 upon 18. Like the previous case, let us find the product by performing the multiplication step by step. First, the whole is divided into 18 rows and 12 columns, creating 12 into 18 equal parts. The value we get by dividing 7 upon 18 into 12 equal parts is 7 upon 12 into 18. Here in the figure, we have 12 columns and 18 rows, thus dividing it into 216 parts, out of which we have 7 parts to be shaded in yellow, representing 7 upon 18. Page number 182. Then we multiply this result by 5 to get the product. This is 5 into 7 upon 12 into 18. So, 5 upon 12 into 7 upon 8 is equal to 5 into 7 upon 12 into 18. That is equal to 35 upon 216. From this, we can see that in general, A upon B into C upon D is equal to A into C upon B into D. This formula was first stated in this general form by Brahmagupta in Brahma's Foot Siddhant in 628 CE. The formula above works even when the multiplier or multiplicand is a whole number. We can simply rewrite the whole number as a fraction with denominator 1. For example, 3 into 3 upon 4 can be written as 3 upon 1 into 3 upon 4. That is equal to 3 into 3 upon 1 into 4 is equal to 9 upon 4. And 3 upon 5 into 4 can be written as 3 upon 5 into 4 upon 1. That is equal to 3 into 4 upon 5 into 1 is equal to 12 upon 5. On the right side of the page, we are provided with a figure in which we have 12 rows and 18 columns, and out of which we have 5 rows and 7 columns to be shaded, and it represents 7 upon 18 parts. Multiplication of fractions. Simplifying to lowest form. Multiply the following fractions and express the product in its lowest form. 12 upon 7 into 5 upon 24. Instead of multiplying the numerators 12 and 5 and denominators 7 and 24 first and then simplifying, we could do the following. 12 upon 7 into 5 upon 24 is equal to 12 into 5 upon 7 into 24. We observe that both the circled numbers, that is 12 and 24, have a common factor of 12. We know that a fraction remains the same when the numerator and denominator are divided by the common factor. In this case, we can divide them by 12. Page number 183. 12 into 5 upon 7 into 24 can be simplified as 12 ones are and 12 twos are, which can be written as 1 into 5 upon 7 into 2, that is equal to 5 upon 14. Let us use the same technique to do one more multiplication. 14 upon 15 into 25 by 42. Here we can cancel out common factors and we can see 14 ones are 14 and 14 threes are 42. Likewise, 5 threes are 15, 5 fives are 25. So we are left with 1 into 5 in numerator and 3 into 3 in the denominator. That is equal to 5 upon 9. When multiplying fractions, we can first divide the numerator and denominator by their common factors before multiplying the numerators and denominators. This is called cancelling the common factors. A pinch of history. In India, the process of reducing a fraction to its lowest terms, known as apavartan, is so well known that it finds mention even in a non-mathematical work. A Jaina scholar, Umaswati, c. 150 CE, used it as a simile in a philosophical work. Figure it out. Question number 1. A water tank is filled from a tap. If the tap is open for 1 hour, 7 upon 10 of the tank gets filled. How much of the tank is filled if the tap is open for A. 1 upon 3 hour is equal to dash, B. 2 upon 3 hour is equal to dash, C. 3 upon 4 hour is equal to dash, D. 7 upon 10 hour is equal to dash. E. For the tank to be full, how long should the tap be running? Page number 184. Question number 2. The government has taken 1/6 of Somu's land to build a road. What part of the land remains with Somu now? She gives half of the remaining part of the land to her daughter Krishna and 1/3 of it to her son Bora. After giving them their shares, she keeps the remaining land for herself. A. What part of the original land did Krishna get? B. What part of the original land did Bora get? C. What part of the original land did Somu keep for herself? Question number 3. Find the area of a rectangle of sides 3 whole 3 upon 4 feet and 9 whole 3 upon 5 feet. Question number 4. Sevang plants 4 saplings in a row in his garden. The distance between 2 saplings is 3 upon 4 meters. Find the distance between the first and last sapling. Hint: draw a rough diagram with 4 saplings with distance between 2 saplings as 3 upon 4 meters. Question number 5. Which is heavier, 12 upon 15 of 500 grams or 3 upon 20 of 4 kg? Is the product always greater than the numbers multiplied? Since we know that when a number is multiplied by 1, the product remains unchanged, we will look at multiplying pairs of numbers where neither of them is 1. When we multiply two counting numbers greater than 1, say 3 and 5, the product is greater than both the numbers being multiplied. 3 into 5 is equal to 15. The product 15 is more than both 3 and 5. But what happens when we multiply 1 by 4 and 8? 1 by 4 into 8 is equal to 2. In the above multiplication, the product 2 is greater than 1 upon 4 but less than 8. What happens when we multiply 3 upon 4 and 2 upon 5. 3 upon 4 into 2 upon 5 is equal to 6 upon 20. Let us compare this product 6 upon 20 with the numbers 3 upon 4 and 2 upon 5. For this, let us express 3 by 4 as 15 upon 20 and 2 by 5 as 8 upon 20. Page number 185. From this, we can observe that the product is less than both the numbers. When do you think the product is greater than both the numbers multiplied? When is it in between the two numbers and when is it smaller than both? Hint: the relationship between the product and the numbers multiplied depends on whether they are between 0 and 1 or they are greater than 1. Take different pairs of numbers and observe their product. For each multiplication, consider the following questions. We have a tabular column here in which the first column has situation, second column has multiplication, and the third one represents the relationship. In the situation 1, both numbers are greater than 1. Example, 4 by 3 into 4. Relationship: the product 16 upon 3 is greater than both the numbers. In situation 2, both numbers are between 0 and 1. Example, 3 upon 4 into 2 upon 5. In relationship, the product 3 upon 10 is less than both the numbers. In situation 3, one number is between 0 and 1 and one number is greater than 1. Example, 3 upon 4 into 5. The product 15 upon 4 is less than the number greater than 1 and greater than the number between 0 and 1. Create more such examples for each situation and observe the relationship between the product and the numbers being multiplied. What can you conclude about the relationship between the numbers multiplied and the product? Fill in the blanks. When one of the numbers being multiplied is between 0 and 1, the product is dash, greater or less than the other number. You need to fill in the blank. Second, when one of the numbers being multiplied is greater than 1, the product is dash, greater oblique less than the other number. Page number 186. Order of multiplication. We know that 1 upon 2 into 1 upon 4 is equal to 1 upon 8. This has been represented in the figure here, in which we have 8 equal parts, and we can see that 1 by 4 into 1 by 2 is shown by the shaded portion 1 upon 8. Similarly, we have 1 upon 4 into 1 upon 2, that is 1 upon 8 too. In the figure, we have 8 equal parts, out of which one portion has been shaded, that is representing 1 upon 8 equal parts. In general, note that the area of rectangle remains the same even if the length and the breadth are interchanged. The order of multiplication does not matter. Thus, A upon B into C upon D is equal to C upon D into A upon B. This can also be seen from Brahmagupta's formula for multiplying fractions. 8.2 Division of fractions. What is 12 divided by 4? You know this already, but can this problem be restated as a multiplication problem? What should be multiplied by 4 to get 12? That is, 4 into dash is equal to 12. We have here in the picture, dividend is 12, divisor is 4, and the quotient is 3. So 12 divided by 4 is equal to 3. Page number 187. We can use this technique of converting division into multiplication problems to divide fractions. What is 1 divided by 2 upon 3? Let us rewrite this as a multiplication problem. 2 upon 3 into dash is equal to 1. What should be multiplied by 2 upon 3 to get the product 1? If we somehow cancel out the 2 and the 3, we are left with 1. We have 2 upon 3 into 3 upon 2, in which 2 gets cancelled and 3 also gets cancelled, and we are left with 1. So, 1 divided by 2 upon 3 is equal to 3 upon 2. Let us try another problem. 3 divided by 2 upon 3. This is the same as 2 upon 3 multiplied by what gives 3. Can you find the answer? We know what to multiply 2 upon 3 by to get 1. We just need to multiply that by 3 to get 3. So, 2 upon 3 into 3 upon 2 into 3 is equal to 3. As 2 and 3 are getting cancelled in numerator and denominators. So, 3 divided by 2 upon 3 is equal to 3 upon 2 into 3, that is equal to 9 upon 2. What is 1 upon 5 divided by 1 upon 2? Rewriting it as a multiplication problem, we have 1 upon 2 into dash is equal to 1 upon 5. Page number 188. How do we solve this? 1 upon 2 into 1 upon 5 is equal to 1 upon 5, as 2 gets cancelled in numerator and denominator. So, 1 upon 5 divided by 1 upon 2 is equal to 2 into 1 upon 5, that is equal to 2 upon 5. What is 2 upon 3 divided by 3 upon 5? Rewriting this as multiplication, we have 3 upon 5 into dash is equal to 2 upon 3. How will we solve this? 3 upon 5 into 5 upon 3 into 2 upon 3 is equal to 2 upon 3, as 3 and 5 get cancelled in numerator and denominator. So, 2 upon 3 divided by 3 upon 5 is equal to 5 upon 3 into 2 upon 3 is equal to 10 upon 9. Discussion. In each of the division problems above, observe how we found the answer. Can we frame a rule that tells us how to divide two fractions? Let us consider the previous problem. In every division problem, we have a dividend, divisor, and quotient. The technique we have been using to get the quotient is: first find the number which gives 1 when multiplied by the divisor. We observe that the resulting number is a fraction whose numerator is the divisor's denominator and denominator is the divisor's numerator. For the divisor 3 upon 5, this fraction is 5 upon 3. We call 5 upon 3 the reciprocal of 3 upon 5. When we multiply a fraction by its reciprocal, we get 1. So, the first step in our technique is to find the divisor's reciprocal. Here we have in the figure 2 upon 3 divided by 3 upon 5, in which 2 upon 3 is dividend and 3 upon 5 is divisor. That is explained as 5 upon 3 into 2 upon 3 is equal to 10 upon 9. 10 upon 9 becomes our quotient. Page number 189. 2. We then multiply the dividend with this reciprocal to get the quotient. Summarizing, to divide two fractions, find the reciprocal of the divisor. Multiply this by the dividend to get the quotient. So, A upon B divided by C upon D is equal to D upon C into A upon B. That is equal to D into A upon C into B. This can be rewritten as A upon B divided by C upon D is equal to A upon B into D upon C is equal to A into D upon B into C. As with methods and formulas for addition, subtraction, and multiplication of fractions that you learnt earlier, this method and formula for division of fractions in this general form was first explicitly stated by Brahmagupta in his Brahmasphut Siddhant 628 CE. So, to evaluate, for example, 2 upon 3 divided by 3 upon 5 using Brahmagupta's formula above, we write 2 upon 3 divided by 3 upon 5 is equal to 2 upon 3 into 5 upon 3 is equal to 2 into 5 upon 3 into 3, that is equal to 10 upon 9. Dividend, divisor and the quotient. When we divide two whole numbers, say 6 divided by 3, we get the quotient 2. Here, the quotient is 6 less than the dividend. 6 divided by 3 is equal to 2. 2 is less than 6. But what happens when we divide 6 by 1 upon 4? 6 divided by 1 by 4 is equal to 24. Here, the quotient is greater than the dividend. What happens when we divide 1 upon 8 by 1 upon 4? 1 upon 8 divided by 1 upon 4 is equal to 1 upon 2. Here too, the quotient is greater than the dividend. When do you think the quotient is less than the dividend? And when is it greater than the dividend? Is there a similar relationship between the divisor and the quotient? Page number 190. Use your understanding of such relationships in multiplication to answer the questions above. 8.3. Some problems involving fractions. Example 3. Lena made 5 cups of tea. She used 1 upon 4 liter of milk for this. How much milk is there in each cup of tea? In the figure, we find there is a line divided into 5 equal parts representing 1 by 4 liters of 5 cups and one part representing milk in 1 cup. Lena used 1 upon 4 liters of milk in 5 cups of tea. So, in 1 cup of tea, the volume of milk should be 1 upon 4 divided by 5. Writing this as multiplication, we have 5 into milk per cup is equal to 1 upon 4. We perform the division as follows as per Brahmagupta's method. The reciprocal of 5. The divisor is 1 upon 5. Multiplying this reciprocal by the dividend 1 upon 4, we get 1 upon 5 into 1 upon 4 is equal to 1 upon 20. So, each cup of tea has 1 upon 20 liter of milk. Example 4. Some of the oldest examples of working with non-unit fractions occur in humanity's oldest geometry text, the Sulbha Sutra. Here is an example from Bodhayan's Shulbha Sutra, c. 800 BCE. Cover an area of 7.5 square units with square bricks, each of whose sides is 1 upon 5 units. Page number 191. How many such square bricks are needed? Each square brick has an area of 1 upon 5 into 1 upon 5 is equal to 1 upon 25 square units. The total area to be covered in 7.5 square units is equal to 15 upon 2 square units. As number of bricks into area of a brick is equal to total area. Number of bricks is equal to 15 upon 2 divided by 1 upon 25. The reciprocal of the divisor is 25. Multiplying the reciprocal by the dividend, we get 25 into 15 upon 2 is equal to 25 into 15 upon 2, that is equal to 375 upon 2. Example 5. This problem was posed by Chaturved Pratudak Swami, c. 860 CE, in his commentary on Brahmagupta's book, Brahmasputa Siddhant. 4 fountains fill a cistern. The first fountain can fill the cistern in a day. The second can fill it in half a day. The third can fill it in quarter of a day. The fourth can fill the cistern in 1/5 of a day. If they all flow together, in how much time will they fill the cistern? Let us solve this problem step by step. In a day, the number of times the first fountain will fill the cistern is 1 divided by 1, that is equal to 1. The second fountain will fill the cistern is 1 divided by 1 upon 2, that is equal to dash. The third fountain will fill the cistern is 1 divided by 1 upon 4 is equal to dash. The fourth fountain will fill the cistern is 1 divided by 1 upon 5 is equal to dash. The number of times the 4 fountains together will fill the cistern in a day is dash plus dash plus dash plus dash is equal to 12. Thus, the total time needed by the 4 fountains to fill the cistern together is 1 upon 12 days. Page number 192. Fractional relations. Here is a square with some lines drawn inside. Here we have a picture of a square with some lines drawn inside and a region is shaded in figure 8.4. What fraction of the area of the whole square does the shaded region occupy? There are different ways to solve this problem. Here is one of them. Let the area of the whole square be 1 square unit. We can observe that the top right square in figure 8.5 occupies 1 upon 4 of the area of the whole square. This has been represented in figure 8.5 by a highlighted square on the right side of the square. Area of the red square is equal to 1 by 4 square units. Here we have another picture in which the unit square has been divided into 2 parts diagonally and half of the portion has been shaded in yellow. In figure 8.6, we have another picture in which we have the highlighted portion of the square, which is 1/4 of the whole square. Page number 193. Let us look at this red square. The area of the triangle inside it, colored yellow, is half the area of the red square. So, the area of the yellow triangle is equal to 1 by 2 into 1 by 4 is equal to 1 upon 8 square units. What fraction of this yellow triangle is shaded? The shaded region occupies 3 by 4 of the area of the yellow triangle. Are you able to observe why? The area of the shaded part is equal to 3 upon 4 into 1 upon 8 is equal to 3 upon 32 square units. Thus, the shaded region occupies 3 upon 32 of the area of the whole square. The shaded portion of the picture has been represented in the right side of the page. In each of the figure given below, find the fraction of the big square that the shaded region occupies. Here we have 2 different pictures in which the shaded area has to be calculated. We will solve more interesting problems of this kind in a later chapter. A dramatic donation. The following problem is translated from Bhaskaracharya's Bhaskara 2 book Lilavati, written in 1150 CE. O wise one, a miser gave to a beggar 1/5 of 1 upon 16 of 1 upon 4 of 1 upon 2 of 2 upon 3 of 3 upon 4 of a drama. If you know the mathematics of fractions well, tell me, O child, how many cowrie shells were given by the miser to the beggar? Drama refers to a silver coin used in those times. The tale says that one drama was equivalent to 1280 cowrie shells. Let's see what fraction of a drama the person gave. 1 upon 2 into 2 upon 3 into 3 upon 4 into 1 upon 5 into 1 upon 16 into 1 upon 4th part of a drama. Page number 194. Evaluating it gives 6 upon 7680. Upon simplifying to its lowest form, we get 6 upon 7680 is equal to 1 upon 1280. So, one cowrie shell was given to the beggar. You can observe in the answer Bhaskaracharya's humor. The miser had given the beggar only one coin of the least value, that is cowrie. Around the 12th century, several types of coins were in use in different kingdoms of the Indian subcontinent. Most commonly used were gold coins called dinars, gadyans, and hunas. Silver coins called dramas or tankas. Copper coins called kasus, panas, and mashakas, and cowrie shells. The exact conversion rates between these coins varied depending on the region, time period, economic conditions, weights of coins, and their purity. Gold coins had high value and were used in large transactions and to store wealth. Silver coins were more commonly used in everyday transactions. Copper coins had low value and were used in smaller transactions. Cowrie shells were the lowest denomination and were used in very small transactions and as change. If we assume 1 gold dinar is equal to 12 silver dramas, 1 silver drama is equal to 4 copper panas, 1 copper pana is equal to 6 mashakas, and 1 pana is equal to 30 cowrie shells. 1 copper pana is equal to 1 upon 48 gold dinar, that is 1 upon 12 into 1 upon 4. 1 cowrie shell is equal to dash copper panas. 1 cowrie shell is equal to dash gold dinars. A pinch of history. As you have observed, fractions are an important type of number playing a critical role in a variety of everyday problems that involve sharing and dividing quantities equally. The general notion of non-unit fractions as we use them today, equipped with the arithmetic operations of addition, subtraction, multiplication, and division, developed largely in India. The ancient Indian geometry text called the Sulbha Sutra, which go back as far as 800 BCE and were concerned with the construction of the fire altars for rituals, used general non-unit fractions extensively, including performing division of such fractions as we observed in example 3. Fractions even became commonplace in the popular culture of India as far back as 150 BCE, as evidenced by an offhand reference to the reduction of fractions to lowest terms in the philosophical work of the revered Jain scholar Umaswati. Page number 195. General rules for performing arithmetic operations on fractions in essentially the modern form in which we carry them out today were first codified by Brahmagupta in his Brahmasputa Siddhant in 628 CE. We have already observed his methods for adding and subtracting general fractions. For multiplying general fractions, Brahmagupta wrote, multiplication of two or more fractions is obtained by taking the product of the numerators divided by the product of the denominators. Brahmasputa Siddhant, verse 12.1.3, that is, A upon B into C upon D is equal to A into C upon B into D. For division of general fractions, Brahmagupta wrote, the division of fractions is performed by interchanging the numerator and denominator of the divisor. The numerator of the dividend is then multiplied by the new numerator and the denominator by the new denominator. Bhaskara too, in his book Lilavati in 1150 CE, clarifies Brahmagupta's statement further in terms of the notion of reciprocal. Division of one fractions by another is equivalent to multiplication of the first fraction by the reciprocal of the second. Lilavati verse 2.3.40. Both of these verses are equivalent to the formula A upon B divided by C upon D is equal to A upon B into D upon C, that is equal to A into D upon B into C. Bhaskara 1, in his 629 CE commentary, Aryabhatiya Bhashya on Aryabhata's 499 CE work, described the geometric interpretation of multiplication of fractions that we observed earlier in terms of the division of a square into rectangles via equal divisions along the length and breadth. Many other Indian mathematicians such as Sridharacharya c. 750 CE, Mahaviracharya c. 850 CE, Chaturveda Prathudak Swami c. 860 CE and Bhaskara II c. 1150 CE developed the usage of arithmetic of fractions significantly further. The Indian theory of fractions and arithmetic operations on them was transmitted to and its usage developed further by Arab and African mathematicians such as Al-Hazar c. 1192 CE of Morocco. The theory was then transmitted to Europe via the Arabs over the next few centuries and came into general rule in Europe in only around the 17th century, after which it spread worldwide. The theory is indeed indispensable today in modern mathematics. On this page, we are provided with a figure in which we have 20 equal parts and 1 by 4 into 1 by 5 is represented as 1 upon 20 in one of the parts out of 20. Bhaskara 1's visual explanation that 1 by 5 into 1 by 4 is equal to 1 upon 20 has been represented in this figure. Page number 196. Figure it out. Question number 1. Evaluate the following. Here we have 12 boxes in which we have questions to be computed. 3 divided by 7 upon 9, 14 upon 4 divided by 2, 2 upon 3 divided by 2 upon 3, 14 upon 6 divided by 7 upon 3, 4 upon 3 divided by 3 upon 4, 7 upon 4 divided by 1 upon 7, 8 upon 2 divided by 4 upon 15, 1 upon 5 divided by 1 upon 9, 1 upon 6 divided by 11 upon 12, 3 whole 2 upon 3 divided by 1 whole 3 upon 8. Question number 2. For each of the questions below, choose the expression that describes the solution. Then simplify it. A. Maria bought 8 meters of lace to decorate the bags she made for school. She used 1 upon 4 meters for each bag and finished the lace. How many bags did she decorate? First option 8 into 1 upon 4. Second option 1 upon 8 into 1 upon 4. Third option 8 divided by 1 upon 4. Fourth option 1 by 4 divided by 8. B. 1 upon 2 meter of ribbon is used to make 8 badges. What is the length of the ribbon used for each badge? First option 8 into 1 upon 2. Second option 1 upon 2 divided by 1 upon 8. Third option 8 divided by 1 upon 2. Fourth option 1 upon 2 divided by 8. C. A baker needs 1 upon 6 kg of flour to make 1 loaf of bread. He has 5 kg of flour. How many loaves of bread can he make? First option 5 into 1 upon 6. Second option 1 upon 6 divided by 5. Third option 5 divided by 1 upon 6. Fourth option 5 into 6. Page number 197. Question number 3. If 1 upon 4 kg of flour is used to make 12 rotis, how much flour is used to make 6 rotis? Question number 4. Patiganita, a book written by Sridharacharya in the 9th century CE, mentions this problem. Friend, after thinking, what sum will be obtained by adding together 1 divided by 1 upon 6, 1 divided by 1 upon 10, 1 divided by 1 upon 13, 1 divided by 1 upon 9 and 1 divided by 1 upon 2. What should the friend say? Question number 5. Meera is reading a novel that has 400 pages. She read 1 upon 5 of the pages yesterday and 3 upon 10 of the pages today. How many more pages does she need to read to finish the novel? Question number 6. A car runs 16 kilometers using 1 liter of petrol. How far will it go using 2 whole 3 upon 4 liters of petrol? Question number 7. Amrit Pal decides on a destination for his vacation. If he takes a train, it will take him 5 whole 1 upon 6 hours to get there. If he takes a plane, it will take him 1 upon 2 hours. How many hours does the plane save? Question number 8. Mariam's grandmother baked a cake. Mariam and her cousins finished 4 upon 5 of the cake. The remaining cake was shared equally by Mariam's 3 friends. How much of the cake did each friend get? Question number 9. Choose the options describing the product of 565 upon 465 into 707 upon 676. A. Greater than 565 upon 465. B. Less than 565 upon 465. C. Greater than 707 upon 676. D. Less than 707 upon 676. E. Greater than 1. F. Less than 1. Question number 10. What fraction of the whole square is shaded? We are provided a picture in which we have a square divided into 4 equal parts and a portion has been shaded. Page number 198. Question number 11. A colony of ants set out in search of food. As they search, they keep splitting equally at each point as given in the figure 8.7 and reach 2 food sources, one near a mango tree and another near a sugarcane field. What fraction of the original group reached each food source? On the right side of a page in figure 8.7, The path followed by the ants is represented with the help of arrows. Question number 12. What is 1 minus 1 upon 2? 1 minus 1 upon 2 within brackets into 1 minus 1 upon 3 within brackets is equal to how much? 1 minus 1 upon 2 within brackets into 1 minus 1 upon 3 within brackets into 1 minus 1 upon 4 within brackets into 1 minus 1 upon 5 within brackets is equal to how much? 1 minus 1 upon 2 within brackets into 1 minus 1 upon 3 within brackets into 1 minus 1 upon 4 within brackets into 1 minus 1 upon 5 within brackets into 1 minus 1 upon 6 within brackets into 1 minus 1 upon 7 within brackets into 1 minus 1 upon 8 within brackets into 1 minus 1 upon 9 within brackets into 1 minus 1 upon 10 within brackets is equal to how much? Make a general statement and explain. Summary. Brahmagupta's formula for multiplication of fractions a upon b into c upon d is equal to a into c upon b into d. Next point. When multiplying fractions, if the numerators and denominators have some common factors, we can cancel them first before multiplying the numerators and denominators. Next point. In multiplication, when one of the numbers being multiplied is between 0 and 1, the product is less than the other number. If one of the numbers being multiplied is greater than 1, then the product is greater than the other number. Next point. The reciprocal of a fraction a upon b is b upon a. When we multiply a fraction by its reciprocal, the product is 1. Next point. Brahmagupta's formula for division of fractions. A upon b divided by c upon d is equal to a upon b into d upon c. That is equal to a into d upon b into c. Last point. In division, when the divisor is between 0 and 1, the quotient is greater than the dividend. When the divisor is greater than 1, the quotient is less than the dividend. Page number 199. Puzzle time. Chess puzzles, non-attacking queens. Chess is a popular two-player strategy game. This game has its origin in India. It is played on a 8 by 8 checkered grid. There are two sets of pieces, black and white, one set for each player. Find out how each piece should move and the rules of the game. Here is a famous chess-based puzzle. From its current position, a queen piece can move along the horizontal, vertical, or diagonal. Place 4 queens such that no 2 queens attack each other. For example, the arrangement below is not valid as the queens are in the line of attack of each other. Here in the figure, we have 4 by 4 checkered grid in which 2 queens have been placed in 2 different white colored grids. Now place 8 queens on this 8 by 8 grid so that no 2 queens attack each other. In another figure, we have 8 by 8 checkered grid in which we are supposed to place 8 queens on this 8 by 8 grid so that no 2 queens attack each other. We can also see some kids, they are wondering to solve this puzzle. This is the end of chapter 8.
Ganit Prakash, you were just listening to this audiobook, Textbook of Mathematics for Grade 7. Narration, Swarnlata Sharma. Sound recordist, Virendra Rawat. Production assistant, Soumya Malik. Directed and produced by Vimalesh Chaudhary. This audiobook is brought to you by CIET NCERT, New Delhi, India.